So you've gotten the hang of creating and running containers with Podman, which is an awesome first step. But what happens next? The real power of containers isn't just about launching them. It's about managing them effectively through their entire lifecycle. In this explainer, we're going to go way beyond the run command and build up those essential skills to control, inspect, and even automate your containers like a pro.
I mean, picture this. On your server, you've got a web server, a database, a caching service, all humming along in their own containers. That's great, but how do you quickly check on their status? How do you safely stop that database for a little maintenance without bringing the whole system crashing down? And what about all those old stopped containers that are just sitting there eating up disk space? Answering these questions, well, that's what lifecycle management's all about. It's about getting complete visibility and precise control over your entire environment.
And we're going to tackle this step by step. First up, we'll learn how to list and inspect our containers to see exactly what's going on. Then, we'll get into actually controlling them, stopping, starting, and pausing. After that, we'll cover how to clean up properly to keep your system nice and tidy. And finally, we'll unlock some real automation power with Quadlets. Let's get started.
All right, first things first. You can't manage what you can't see, right? Before we can control anything, we need visibility. So this whole first section is about getting a really clear picture of our container environment. And our most fundamental tool for this is the Podman PS command. Honestly, just think of this as your mission control dashboard. When you want it, Podman gives you a neat list of every single container that is currently active and running on your system. It's your go-to at-a-glance view. And here's what that output looks like. Each column gives you a vital piece of information. What's its unique ID? What image was it built from? What's its current status? You can see here, up just means it's running. And what name did we give it? It's a really concise, powerful summary of all your active services. But what about containers that have finished their job, or maybe ones that we stopped earlier? By default, Podman PS only shows you the live stuff. To see every container on the system running or not, you just add the -all or the shorthand -a flag. This gives you a complete historical view of every container that has ever existed on your host. Now, sometimes that high-level list just isn't enough. Maybe you need to debug a network problem by checking a container's IP address, or you need to verify an environment variable. For that level of detail, we need to inspect the container. And that means retrieving every single piece of its configuration and current state. Okay, but there's a catch. When you run Podman Inspect, it doesn't just give you a few details. It returns a massive, and I mean massive, JSON object with everything you could ever want to know about the container. Trying to find one specific value in there can feel like looking for a needle in a digital haystack. It's just way too much information to parse by hand.
And this is where Podman gives us an incredibly elegant solution, the -format flag. This powerful feature lets you use what are called Go template expressions to query that giant JSON object and pull out exactly the field you're looking for. You just specify the path to the data you want, like .state.status, and Podman filters out all the other noise.
And the difference is just night and day. Without the format flag, you've got hundreds of lines of JSON. With it, we ask for just one thing, the status. And the result, a clean, simple, and incredibly useful answer, running. This technique is absolutely essential when you start scripting and automating things.
All right, so now that we have visibility, let's move to the next phase, control. It's time to learn how to actively manage our containers by stopping, pausing, and restarting them safely and effectively.
Before we stop anything, we need to understand a really critical concept, graceful shutdown. You don't just want to pull the plug on an application. A graceful shutdown gives the process inside the container time to save its data, close network connections, and clean up any resources. This is the professional way to stop a service, and it helps prevent data corruption.
The Podman stop command implements this graceful process perfectly. First, it sends a SIGTERM signal. You can think of this as a polite, official request for the application to terminate. Podman then waits for a default of 10 seconds, giving it that grace period to shut down cleanly. If the container is still running after that time, and only then, does Podman escalate by sending a forceful SIGKILL signal to terminate it immediately. And this really shows the contrast between the two approaches. Podman stop is that polite request, using SIGTERM and providing a grace period. Podman kill is the immediate, forceful termination with SIGKILL. No questions asked. The rule is simple. Always try stop first. You only use kill when a container is completely unresponsive.
Beyond just stopping, we have a few other controls in our toolkit. Podman Pause is useful for temporarily freezing a container's state without terminating it, which you can then resume with Unpause. And Podman Restart is a convenient shortcut that works whether the container is currently running or stopped.
Once a container has served its purpose and is in a stopped state, it's not gone. It's still taking up disk space. So the final step in the manual lifecycle is to properly remove it, ensuring a clean and efficient host system.
The command for this is Podman ARM. Now it's designed with a nice safety feature. By default, it will only work on containers that are already stopped. This helps prevent you from accidentally deleting a live application. If you really need to override this, you can use the -force flag. And to clean up all stopped containers at once, the -all flag is your best friend.
Everything we've covered so far has been manual, and that's great for learning and development. But for real-world applications on servers, we need our containers to be managed automatically, just like traditional system services. This is where we transition from the command line to a declarative, automated approach using Quadlets.
So what exactly is a Quadlet? Think of it as a bridge or a special instruction manual for systemd, the core service manager on most Linux systems. It's a simple text file where you declare how your container should run. Systemd reads this file and automatically generates a proper system service, allowing you to manage your container with standard commands and, most importantly, ensuring it starts automatically on boot.
Let's look at the anatomy of a basic Quadlet file. It uses a simple, readable format. The unit section is for us humans. It just provides a description. The container section is where the magic happens. This is where you define which image to use and what command it should run. Finally, the install section tells systemd to automatically enable and start the service at boot.
Now, after you create or modify one of these .container files, there is one absolutely critical step. Systemd doesn't know about your changes yet. You have to tell it to rescan its configuration by running systemctl daemon reload. This makes your new container service visible to systemd and ready to be managed.
We've covered a lot of ground, from basic inspection all the way to full automation with systemd. So let's take a moment to summarize the key tools and concepts that now form your personal container management toolkit.
Here are the essentials you've mastered. To see what's running, you have Podman PS. For surgical detail, you'll use Podman Inspect with the powerful -format flag. For safe shutdowns, your default is Podman Stop. For unresponsive containers, Podman Kill. For cleanup, you have Podman RM. And to elevate from manual commands to a managed service, you now have Quadlets for deep systemd integration.
This brings us to a final, important thought. We've mastered the lifecycle of an individual container, but modern applications are rarely just one container. They're complex systems of multiple interconnected services. So the next logical question is this: how do you manage the lifecycle of an entire multi-container application as a single, cohesive unit? That is the next step in your container journey. Thank you for watching.